In this class, we study about the multiplexer and demultiplexer. What do you mean by a multiplexer? Multiplexer is a device that allows digital information from several sources to be routed into a single line for transmission over that line. So the multiplexer is mainly used for transmission. For transmission purpose, if you need to transmit the different inputs which is being fed here, that is being routed into a single output. The total number of inputs it will be 2 raised to n, and the one output will be only 1. So n will be starting from 1 to infinity. 1 to infinity, and output will be only 1. So the multiplexer, the basic type of multiplexer will be 2 is to 1, and the multiplexer may vary, that is 4 is to 1 multiplexer, it can go for 8 is to 1 multiplexer, 16 is to 1 multiplexer, 32 is to 1 multiplexer, 64 is to 1 multiplexer, like that it will goes on increasing. And it also has a data select inputs which permit the digital data on any one inputs to be switched into the output line, so that it is that whichever the input which you are giving, this all the inputs will not be given to the output, though only the selector switches will decide which input should be given at a time to the output, so that we are having a selector switches. These selector switches will decide which input should be given at a time. See here, we are having 2 is to 1 multiplexer, we are having only one selector switches. So 2 is to 1 multiplexer, say we are having for 2 is to 1 multiplexer we are having only 2 inputs and only one output and only one selector switch. So when selector switch is equal to 0, this input, that is D0, will be given to the input. If D0 input will be given to the output. When the selector switch is 1, the D1 will be given to the output. So similarly, if you are having the total number of input as 4, so the selector switch will be a 2, so that the selector switch will be having combination of 0 0 0 1 1 0 and 1 1. When 0 0 will be there, then the D0 will be given to the output. When 0 1 will be there, when the D1 will be given to the output. When D1 0 will be there, the D2 will be applied to the output, and when D1 1 will be there, the D3 will be directly routed to the output. So the selector switches will select which data from the input should be given to the output. So it will also becomes a data selector. This will multiplexer will also become a data selector. Whichever the data which you are having, that data should be selected and it is being transmitted. So so 2 is to 1 multiplexer. A logic symbol of 2 is to 1 multiplexer is as shown in the figure. Actually, we are representing the multiplexer in this way. So this is the general representation of multiplexer, and 2 input and 1 selector and 1 output. So D1 and D0 and selector signal S0. If the selector line S0 is 0, then the output D0, and if the selector line S0 is 1, then the output will be D1, which I told you now. So similarly, for S is equal to 0, so similarly then we are having, when we can write down the output, the equation for the output, Z is equal to D0 into S0 complement plus D1 into S0. So like this we can write down. So when the S0 is 0, then 0 complement will be 1, then Z is equal to D0. then d1 into 0, it will be 0. When s0 is equal to 1, d1 into 1, d1, and s0 is equal to 1 complement 0, then z is equal to d1. Z is equal to d1 here. So like this we can have the generalized equation, and you can directly implement this d0 and s0 by using and not gate. So by using and gate, say we are having two input d0 and d1, and we are having the select line s0. For d0 into s0, s0 complement, we need to have a complement here, so we can put it like this, and s0, and you can AND it in a AND gate, and you can give it here, and d1 into s1. So here we can take by using the AND gate, one more AND gate here, and give it to the OR gate. So this is nothing but the realization of this equation by using the and OR gate. By and OR gate you can realize this equation. So this equation you will be getting from this truth table, and that truth table you are getting from a logic, that is only one input will be routed to the output. At a time only one input is being routed to the output. This logic is being applied here, and from this logic we are getting this equation, and from that equation we can implement this circuit. Say for 4 inputs, say for 4:1 multiplexer, we are having the multiplexer, we are having the inputs as D0, D1, D2 and D3, and the data select line S0 and S1, and the data output will be only one. So that is why we are having only one output. That is why we are using the multiplexer for data transmission, not for the receiving. So for transmitting we need to have only one line, and we are having different inputs here. So we can select whichever the input which we can transmit at a time. അതായത് ട്രാൻസ്മിറ്റ് ചെയ്യുമ്പോൾ എല്ലാ ഡാറ്റയും ഒറ്റ ടൈം നിങ്ങൾക്ക് ട്രാൻസ്മിറ്റ് ചെയ്യാൻ പറ്റില്ല. അപ്പോൾ ഏതാണ് ഇൻപുട്സ് ആണ് വേണ്ടത്, ആ ഇൻപുട്സ് മാത്രമേ നിങ്ങൾക്ക് ട്രാൻസ്മിറ്റ് ചെയ്യാൻ പറ്റൂ. ഫോർ എക്സാമ്പിൾ, യു ഹാവ് ഇൻ എ മൾട്ടിപ്ലക്സർ വി ആർ ഹാവിങ് different inputs. Say we are having the headphone from PC, we headphone from your mobile, sorry, we are having the mobile here. We are connecting the mobile, we are connecting the PC, we are connecting the desktop, we are connecting it to the other sources, say CR. So whichever the inputs which we have to transmit at a time. So if you are selecting it, we are having two data select lines, S0 and S1. So when S0 is equal to 0, 0, we can transmit the information from mobile to the output. When S0 is equal to 0, 1, we can transmit the information from PC to the output. When S0 is equal to 1, 0, we can transmit the information from desktop to the output. When S0 is equal to 1, 1, we can transmit the information from CRO to the output. So this will be transmitted and to the output. So similarly, that type of data select lines we call as S0 and S1. So the data select line will form a very good important part in a multiplexer. So the figure, if S0 is equal to 0, 0, it is applied into the data select line. Data on the input D0 appears on the data output line. So you see here, when S0 is equal to 0, 0, the input select line will be D0, when 0, 1, D1, 1, 0, D2, and 1, 1, D3. So these are all things, and